Well, this one looks relatively painless, but if you don't look close enough, it's a little bit more than you might have originally bargained for. And in fact, I'm going to really require some space here. So I'm going to go across. That's not going to work out too well. Okay, up here. Um, the reason I'm about to make it so big is I need that many compartments, 6 wide. Okay, so I kind of cut it in half and then cut each half into thirds. That should be enough. You might say, well, that's crazy because there's only these two guys here. Yes, that is true. But there's a lot of zeros you got to include. Something like this, you may even want to start on this end. Okay, I got a -1, I got a 0x, a 0x squared, a 0x to the third, a 0x to the fourth, a 0x to the fifth, and then your x to the sixth power is all the way out yonder. Okay, you'll see a pattern, and eventually it develops into something that's pretty straightforward. But you got your x to the sixth power there, and an x to the fifth power up there. That and a -1 is a -1x to the fifth. So what you'll find is that this will end up being negative because of that. This has to be positive to cancel, so it's a 1x to the fifth power, which means up here this is just going to be an x to the fourth power. Times a -1 is a -1x to the fourth. Well, again, we've got a 0, so the same thing is going to hold true pretty much all the way down. Plus x to the third, -1x to the third, causing us to have a positive 1x to the third, creating an x squared, and same thing will happen. That's an x, and then finally, it's a 1. And just to confirm, x times -1 is a -1x. This has to be a positive 1x. 1 times -1 is a -1, and they do in fact match. And I skipped one, but still, trust me, we're right there. And that is the solution.